red2a red class. This is Monday, April the 10th. We're in week 3. Our goal is to finish this unit off this week, begin tasting some of the new stuff next week, even if I have to try and share time. We'll see what it looks like. So let's do this. Let's try and create a table. Do me a favor. We're about to make the connection between a linear graph and an exponential graph. So we're going to make actually 2 tables. Let's see what their page looks like. We'll have to use the top section for some of them. Maybe use the bottom. So you kind of work this page as best you can. But here's what I want you to do. I'm going to use my space, but basically you're going to create 2 halves. You have the power to do that. You're going to create 2 halves. One half will go with this formula here. I want you to see a difference here. So again, one of your tables is going to be, of course, y equals 7x. The table will have an x side and a y side. We're going to fill in 0, 1, 2, 3. And again, by doing this, should get to be one of your 6 pages as a little gift from me to you. The other problem, I want you to notice the difference. I'm going to put part of it in red. Y equals 7 raised to the x power. So the left side, as you're writing, is going to look like something you did maybe in algebra. It's a regular linear equation. This one, we'll see if we can even get some answers without the calculator. And then we'll actually put it in the calculator so we can see it. The second one, we're going to see what people can say without the calculator, and then we'll put it in the calculator. So hopefully people will notice the difference between the two. Oh, this is green. So basically, we're going to create 2 tables, and then we're going to see if we can sketch the graph for each one of them, and let that hopefully be one of the pages. 0, 1, 2, 3. So you're creating these 2 tables. No big deal. Now again, where you put them, your space, depending on if you've written on that page, where you're going to put your 2 tables, that might be a little tricky. All right. There are 4 tables. True. Let's start on this side. Y equals 7 times x. If you put a number in the place of x, like a 0, you just multiply that number times 7, and it tells you what this side should be. So once you give an answer, you can leave the other one alone. If you can do one of the harder ones, then hold off on answering one of the earlier ones. And then we'll kind of try the same thing over here, but it might be a little bit different. Then we'll mess around with our calculators, do it there, and then just see the difference between these 2, though they look alike. For the first one, we put a 0 in the place of x. 0 times 7. Say it again. We got a 0 there. Maybe I should just kind of keep this going. I'm going to get blue. All right. Somewhat different when I put a 1 in the place of x. 1 times 7 will give me 7. Yeah, no big deal. So these is what's called a linear equation. It's just going to keep adding on. Someone when I put a 2 in the place of 7 and 14. And you can almost do these by just adding 7 along. You'll see plus 7, plus 7. What's that last line going to be when I add 7 to 14? Yeah, 21. It's called a linear equation. This other side, though, he does a little different. And when we put these equations, we're going to put them both into our calculator in just a moment so they can both be in the same table. We're lucky, though. Well, let's see what happens. Anyone know what 7 raised to the 0 power is? 7 is a good guess. What is it? 0 is a good guess. This one, let's punch it into our calculator so we can see what the number's going to be. Put in, go to your y equals. You can put in 7. Then you have to hit that caret button. The caret button, right below the clear button over in the upright over there by the arrows. That caret button looks like upside down V, and then raise it to the x power. Where x is again? Right next door to the. Right next door to the. So the green button, you'll see the x, the t, the theta, the n. That'll get you an x. So right now, you should have y equals 7 raised to the x power. So you put in a 7, you get that caret button right below the clear, it's all the way to the right by those gray arrows. let me stop recording for just a moment because they don't need to stare at the board while they hear me walk around. Exponential functions are ones that grow big really fast, which is why if you put your money in the bank right now, let's say if you turn 18 to, like say from 20 to 30, you put a little bit of money in the bank, actually from 20 to 25, I think it says 5 years, you put $100 in the bank, or an account that will grow exponentially, and then you leave it after 5 years. Don't do anything with it. 5 years, do this. When you go to 65, which is forever away, $1 million will be waiting for you. You didn't have to do anything. It's because every year it expands, it gets bigger and bigger. So let's try this. I'll try this table here for the 0, this one for the 1, for the 2, for the 3. If you need some help, we'll get you some backup. So go to blue button table, if you haven't already. Take up here. Can't you get anything? What's the partner to 0? It is 0. Turns out. That should be a different number. Anybody have a different partner to 0? You have a 1? Or is it there? If you're white. That thing just got switched on yours. Type in, retype in this new thing. I hear 1, I'll come back around so you get to get 3. But type in this equation here. I don't know how to switch to that other thing. Alright, I'll come this way for so they did 1. Let's do that back table with Robert and Dina for 2. So what do you guys have there? And the way you gotta think of it is this: anything raised to the 0 power is 1. That part is true. Then when it's a 2, 7 raised to the 2nd power, that's 7 times 7. That is 49. Okay. Do you have that row with the 1 and the 49? David? Oh, yeah, you're right. That second row shouldn't be the 49. The second row should be a what? Yeah, that second row should be a 7. And that third row with the 2. And then Candy George finally got fixed. What's the partner to the 3? 343. And so what these things do is this. They grow exponentially. In other words, whoever's on the last row, he gets multiplied by 7. And the guy, whatever that answer was, he gets multiplied by 7. And that guy. So exponential functions, you should think, is this. Exponentials, you get multiply the last guy by the same number. Whereas linear, they get there. They get added. So let's see, is there any way to graph these guys? We'll do these with the dots. But again, you may recall about the airplane. We draw an airplane for an exponential function. So let's see. How would I want to do this? Well, you can just follow along with me. Let's see. 0, 1, 2, 3. And these dots, I'll make them multiples of 7. Let's see if I can do that. So for this one here, we have 0. Oops. 0, 1, 2, 3, and then we'll back up to the other page. After these 2 problems on this page, we'll look at the cow problem, and then again, even with the small numbers, still my goal. The more people I have to address their tests and what's broken, then the better. All right, so let's see if I can graph this thing. 0, 1, 2, 3, 4. I'm going to scale this one here since I'm going to be using multiples of 7. I'm going to put you at. That can't be right. So I make you. I'll try to see what happens. 7, 14, 21, 28, 35. Why is he nervous about that? Why would Thomas be concerned with that? Because if this little block here says that I'm equal to 1, how can this block here say I'm equal to 7 when we're the same size? Something feels wrong about it. I'm going to do it. Something feels wrong about it. When I get your papers, is this one of your 6s? Yeah, it'll be fine. All right, so here we go. So for the linear, it says 0. I'll do this one in blue. I'll do this one in black. So 0, comma 0. The next guy is 1, comma 7. And you can write in the same thing. That way, this page will be could be one of your sixes. 2, comma 14. Notice it makes a line. I'm gonna write word over here, linear, and then 21. So technically, if I were connecting this one, it'd be a straight line. I write down the formula, and I'd want you to do exactly the same thing I'm doing. Y equals 7x. I'll pause to give you a moment. My goal here isn't to teach you how to graph a linear equation. My goal is to make the comparison between the two. That it's where the x is. It's where the x is next door, side by side. 7 times x makes a linear versus an exponential. I'm going to do this exponential because the numbers grow so fast. It's going to be crazy. So obviously you don't have another color. You may have a highlighter once you do the second one. The second one, let's see, 0, comma 1. Yeah, it's not going to work out. 0, comma 1, 1 would kind of be there. 1, comma 7. Then 2, comma 49, which I don't have up there even. But what you're going to see is this airplane. The airplane takes off through. And this guy here is y equals the 7, basically x power. Exponential. How fast does your money grow? So in 1 month, this thing goes to 7. In 2 months, this thing is like super high already. Exponential growth. So the last thing I'm going to write on this page, now that you get to see that the comparison between the two. On this side here, we put linear. I wish I could have a color for this equation over here. Linear line. See, and in front over here, I wish I could. Exponential. We're going to back up to that other page in a moment, so at least you will have. I don't know if we did any boxes on the back, but at least you have the 2 front boxes, and you do the boxes on the back. You'll have access to that. Alright, so let me pause so we can have a chance to stay in. Or, over here, is this a linear function or an exponential function? This is still on page 1, page right next door to what we are on. And so on this one here, the way you're going to try and tell is the following. I want you to write down the range. So let's type that word range. This takes you all the way back to Unit 1. Unit 1 is where we use the phrase domain and range. Write range there. And what I'm going to have you do is I'm going to have you write out the numbers of the range as a sequence. That's what it's a sequence. In other words, you're just going to have us write the numbers separated by a comma. Numbers separated by a comma officially are called a sequence, especially if there is a pattern. And then what I'm going to see if you can do is to figure out what the pattern is so that you can add on the next 2 numbers in that sequence. So just like I have on the board, you wrote out the numbers of the range, the y numbers. And then just try to see if you can figure out what the next number would be. Part of also what I'm going to try and have you figure out is what are they doing to go from the first number to the second, and then from the second number to the third. All right, let's find out what we may have guessed at. Let's say what it is we need to do to go from 14 to 21. Add, subtract, multiply, divide. What do we do? Add 7. Uh-oh. To get from 21 to 35. Uh-oh. Let's say what it is we do to get from 21 to 35. I wonder if they messed up. going to be a 28. Someone do me a favor, do 35 minus 21. Let me see what that's. 14. And then let's try this. I wonder if the pattern's going to have. Do 49 minus 35. It does 14. Huh. And then do that last one. This is a weird problem because it's not following any pattern at all. 21 is coming from so when you're starting to look for patterns, usually you try and find out what the difference is. Now, again, well, let me ask what you would guess. I know what I'm about to guess. Someone guess what is going to be the next number here. I got a 7, 14, 14, 21, and it looks like 21 is going to be the next number in the pattern. And then if it's 21, 21, probably what will the next number be? I'm thinking it could be 14 that could go back down, but I think they're going to go up to the next of your 7 timetables. They're probably going to do 28, 28. So we'll just do one of those 28s. Again, this one for sure, with your having been here, this one is definitely going to be a benefit to you. Because I don't see someone else just figuring out.
So we're on the first use as the sort of choice because it goes from 2 to 3, which is adding 2 to 5, which is adding 2.
Say that pattern again slow so I can follow you.
It goes from 2 to 3 is 1, 3 to 11 is 2, 7 is 2, 7 to 10 is 3,
Now those 3s, oh I see, and then you want to. And that produces these red numbers for you, or what? Once you have this, what did that do for you when you chose those? Because it's fun. Go on. Because I can kind of see it like these 2 2s in my mind when I see them. So like 2 times 7 is the 2 14s. But somehow they never mentioned a 7 8. So this is kind of a weird problem. Nonetheless, let's do this. Let's find out this 71 plus 21 gave us a what? It was a 91. And then the next one in line, the 91 plus 28 gave us a what? So again. So by being here, you kind of get a preview on these. Right then, these problems. I can tell you one thing that it's not. It is not a linear function. But let me ask, does anyone tell why we know it's not a linear function? The hint is the last problem we did with the 7s. I'm going to come back to it. To be linear, the number you add has to be exactly the same number. And it also almost looks like it's not exponential. So I'm going to go back and put neither, and that'll be a benefit to you all who are here. Exponential is your only choice, but I'm going to actually put neither. Because this is a weird problem that they would lead off with. That's all odd. Here. When you're given a sequence, your job is to try to figure out the pattern. How do you figure out the pattern? You just ask yourself, do they add, subtract, and multiply to get from one number to the next? If they add it, then you put down what number they added. You do it a few more times, and eventually you kind of see a pattern. This pattern is kind of weird, so we'll leave it there. All right, give just a couple by 7. So the first one times 7 gives you the 14. The second one times 7 gives you the 21. So that's kind of weird that we were looking at, or at least I was looking at that part there instead of just comparing this side to this side. So it turns out that neither, you can put a big X through it. Miguel is right. It's linear. In other words, the equation that goes with this is y is going to equal 7 times whatever the x is. That is crazy. And that's a good, I feel like that's a good experience. For it's just the idea that what seemed really tricky and hard, looking at it one way, can actually be much easier looking at it a different way. But it takes someone else to kind of go, hey, have you looked at it this way, which is kind of what they want a little bit more with Common Core. Number one, make sense of the problems and persevere in solving them. That's the number one idea. That one, and it goes along with number three also, construct viable arguments and critique the reasoning of others. In other words, hey, look at it, and then say to someone else, hey, I think this is what's going on, and this is why I see it. And then it's my job to go look at it like, wait a second, yeah, that's true. That's another part they want. All right. Last piece I want us to do before, again, I give you your assessment. You look at your score, identify where there's a 1 that tells you what standard you're going to look at. If your numbers that are covered in here, our numbers are okay, then your job, you're starting to mess around with your 6 pages. And I'm going to also try and get some whiteboards. The last one I kind of want to remind us of, just in case standard 2 is a key for you, is page 69. This page, right now, I'm not expecting us to use this one as one of our 6s. I'm not expecting it. So I'll see if it becomes an emergency where there's just nothing else out there, then try and take care of that. So page 69, the cow problem, I'm just going to build it. You already have it. And after we build it, then I'll let it go. 69. All right, this one I'm just going to walk through just straightforward. I'm not going to do much with it. I might ask for you to kind of help me out with it. But I hope it's in the next 7 minutes or 6 minutes, I will be able to pass out to you. If you know, though, some of you won't know. But if you know standard 1, standard 3, you might have issues. That notebook paper is going to be an important one eventually. All right, so here it comes. Let's see if I can get this guy together. The famous cow problem. This problem is famous across the U.S. If you find yourself in another state, you may hear them talking about the cow problem. This one, E. coli, bacteria population in cow grows exponentially. Of course, I'm going to pretend like you haven't done it, so I'm going to tell you to underline things as if. But I expect if I said this exactly the same way before, you probably have that underlined exponentially. And it grows at 3.2% each year. That rate is always going to be your B. If you ever get these problems where stuff begins and how much it's going to grow, A is where you started, what was the initial amount, and B, of course, is going to be that percent. The average cow starts off, there's that starts, I wish they could double underline that, with 5 billion E. coli bacteria. So step 1, create an equation. Some people wrote down the equation, but they didn't fill in the numbers. The only 2 numbers you need is the A and the B. The X stays the same. Can someone say out loud what the A is going to be, what the initial amount was? Is that 5 billion? Now you just need the B. Again, the B is always going to be the percent, but you got to do something with that percent. So let me do something with the percent right over here. Where do I want to do something with that percent? I'm going to do it right here. Well, let me go up here. There's a 3.2%. You have to change that percent into a decimal. How do you do that? I'll write it down here. I know they already have it somewhere. 3.2%. You cross out the percent sign. Cross out 1, 2. Always 2. Fill in that egg with a 0. You have 1, 0, 3, and a 2. So I turned it into a decimal. I'm getting ready to put that thing right here in a parenthesis here with B. And it has to be raised to that x power, so people forgot to put that little x. It has to be out there, otherwise I have to mark it. Without the x floating in the sky, it's not exponential. It's going to be linear. Can someone remind me what we have to put in front of this 0.32 when we put inside the parenthesis? 1 is correct. So inside, this one I'm going to write in red so it can stand out. 0.032, but there has to be a 1. Now this is a long reason why it has to be there with exponential growth. Technically I did 1 plus 0.032. If it was decay, you do 1 minus 0.032, and it'd be a little smaller, weirder number in there. But for our purposes, I'm saying, look, just put the 1 there. If it gets to decay, I'll explain how to do that. There's a point. Once you go ahead that. second thing I told us is, hey, to draw the picture for an exponential function, because we did it several times in your packet, it's just an airplane taking off. Airplane takes off here. In this case, 5 is where it's going to break through the wall, so I'm actually going to make the 5. Oh, no, I won't make the 5. I'll just let the airplane take off. Now, if when you draw this picture, you drew it to scale, you had 1, 2, 3, 4, 5, and it flew through 5, you're even better than the average student. But, again, for our purposes, I think it's okay to know, 1, the picture of an exponential function, whether it's cows, whether it's whatever they describe, no matter what the b is, you just fly that airplane up. The other thing you have to figure out is where it's going to crash through the wall, the y-intercept. Can somebody say where it's going to crash through the wall? Thank you for thinking it. 5 is it. 5 is where it's going to go through the wall. This 5 is also called the y-intercept. And so a regular 5 here, in coordinate form 5 here. Some people did, they put it on the picture, but they didn't put it over here. I may have put a question mark that we were missing over here. So I do want you to put that in over here. And there's your intercepts. We got our picture, got our intercepts. All we need to do now is that last piece, which is end behavior. After that, again, this is my goal today. Help them get part of their 6 pages, that other 2 prompts we did. Remind them of this guy, just in case this is one of the ones that they missed, standard 2. As a matter of fact, even if you want to put standard 2 on here, you can. After that, show them their test for 5 minutes. The 5 minutes is going to seem short, but you're just looking through and then trying to find notes that go with the section that you need. Once you do that, I will take the test back. You'll review. You take the part that you need, then you'll start working on those 6 pages. Again, next class, some of you will for sure be able to step out early because my main goal will be to utilize as much time as possible on that. So if you're all caught up, either A, if you have another class after this, bring some work to work on for the next class, or B, if you have to shift out early, I understand that as well. All right, let's see. And behavior, I already had it on here, but I'm still going to build it. If we had a highlighter, we would chop this thing in half. So you're going to chop it in half. Yeah, I chopped the picture in half. And the rule simply says this. What's happening to the arrow as they go to the right? And I see some people did a good job with this. They put their arrow to the right, and they can see that the red one goes up. As they go to the right, the red arrow goes up. Some people did this thing where they put a positive infinity over here and a negative infinity over here. I appreciated that because I could see how it helped. The positive infinity, negative infinity. So for the green arrows, as the red picture, the graph, as we move to the right on the axis, as x's go towards positive infinity, the y goes up. This red line goes up. All right. Most people kind of did pretty good with this part. The blue. What happens if you go the opposite direction? Well, as we go to this side of the picture, the left side of the picture, the arrow is coming down. Now, this arrow wants to go past this line, but this line, I remember the name of this line. Asymptote. Asymptote is a line that a graph approaches. The line approaches, but it never touches. Never. So what does this look like? Well, as the blue arrow goes to negative infinity, the red line tries to go down, but it gets stuck at this line. This line happens to be 0. See, if you're on a y line, there's 1, 2, 3, 4, 5, negative 1. Well, this line here, also called the x-axis, happens to be where y equals 0. Take